And welcome to this video. In this video we're going to try and to explain to you function types as return types, and I'm also going to give you a little bit of a snippets from closures, and so we're just going to see how this one video goes. But ultimately what you should learn from this is function types as return types. So let's just move this out of the way first of all, and let's just say function, and we want to say gets increments store. That's what our function name is going to be, and what we want to have is a return type on this of something that can be called as a function, doesn't take any parameters, and then returns an integer. Okay, this is what we want to get from this. So to do this, we can then just basically say return a closure, right? Because we don't have any parameters, and then we can just return here num. Right now, num hasn't been defined yet, so we're going to define num as 0. Okay, and as you can see, the compiler is perfectly fine with this, and we're going to say store 1 because we've got store down the bottom. We've got store down the bottom, and we're going to say increment store here. And now we build it. Everything is perfectly fine. Let's have a look at the type now. Now you can see that we have a function type, and store1 is a function, and it has then it is called without any arguments. It has no parameters, and its return type is of integer. Okay. Now every single time we call store1, right, because it returned a function here, we return it. We call it, and it returns then the num inside of here. Okay. Now, what's magical about inside of this? We could actually remove the return type, the return keyword on num. All right. Now, what's magical about this is that this function call here, we can this store here, we can pass as a function and use it as a function in all of our code, right? And it brings with it this num here, all right? And because this num is included inside of the increment store, so it got wrapped inside of this increment store, and it is contained in this, and now it is fully accessible inside of this store 1. From the usage side of it, we can never access this store, this num here, but we can use it. So this is a potential reason why you would want to use function types as return types. Okay, and it becomes really useful in the future, right? Because you have something called closure, and you have scope, right? That the scope of this one closure includes its parent scope and its parent scope, right? So this function can access everything within inside of its parent scope and within inside of the global scope as well. This is not very clean if you go outside of your parent scope. That's not super clean, but this way of doing it is clean. So this is giving you an example now of how and why we could use it. So that was using a function. Now let's use a little bit more of function types with nested function types, returning function types, all right, using closure. So you can see here we have an increment store. And when we look at the type of this, you can see that it's a function type that returns a function type. So here, the brackets and the return type, this is the return type of the function type, okay? And this is then the declaration. So it's saying, hey, I'm a function that takes no parameters, all right? Here, and my return type is a function type that also takes no parameters, and its return value is of integer, okay? So this is a return type here. And inside of this function body, we are declaring and initializing a num variable of type integer at 0. And then inside of this, we are nesting another function type. So we are creating a variable called increment, and that is of function type that takes no arguments, has no parameters, and returns an integer. And inside of here, we're being a bit more explicit. Look, we are saying using the brackets and the in, but we actually don't need to do that. All right. As you can see here, we don't need to do it because it doesn't have any parameters and it's just wasted code. If you do have parameters, then you need to explicitly add them here. But because we don't have any, you can actually remove it, all right? And inside of this, we are accessing num because it's in its parent scope, and we are incrementing it because it's a number, it's a variable, sorry, so we can, and then we are returning that. And then inside of the actual function body of increment store, we are returning another function type, the implementation of it, and here we are returning, or we are calling the increment function here, and we are returning its value, okay? And we can obviously remove the return keyword there because we've got it's the only expression, it's the only line containing expression, so we can return it as well. And so now down here we say, okay, we're going to generate a store and using the increment store here, all right? And now every single time when we call it, you can see it's outputting already 1, 2, 3, and 4. This var num is keeping its value because this var num is stored inside of store here, and every single time we call it, it's getting incremented all the time. And so you can see here that this can be really, really important to be able to do, all right? And we're not having generated any structs, any classes, anything like that. This is all self-contained in one thing, okay? And this is what if you use Redux or anything like that, this is kind of like what I just don't want to complicate things. So this is returning types as function types as return types, all right? And I think this is a super important thing for you to understand how to do. And don't worry about it. I'm going to go into closures a lot more. I'm going to go into scope a lot more. But I wanted just to throw this at you, showing a real world example of using this type of stuff. And these type of words, stores and function and return types, you're going to see this a lot more when you go and look at other things. With that said, I hope that you've learned something from this one video. I hope that you've got something took away from it. Don't worry if you haven't got this 100%. As long as you can get it more than 50%, as long as you go, okay, I know what he's talking about, but he said that closures and scope are going to be taught in the future, so don't worry about it. You just need to understand how to define a function type here. And this is the most important part to take away, is how do you define a variable with a function type on it, all right? So with that said, thank you very much for watching, and if you do have any questions, concerns, feedbacks or anything like that, let's start a conversation in the comment section down below. Thank you very much for watching. See you in the next video. Ciao, ciao, and goodbye.